Okay. When we last left our data, we had just constructed a frequency distribution from the raw data, and we talked about using this to see a pattern in the data. Usually when people talk about seeing, though, they mean pictures, not numbers. So let's learn how to make a picture of the frequency distribution. The picture is called the frequency histogram. All right, so here we have our place where we're going to draw the picture. We have an x-axis and a y-axis. And to start, we draw the classes of our variable, the values of our variable, on the horizontal or x-axis. Or if you want to sound really sophisticated and make sure half your audience doesn't understand you, call it the abscissa. Then we put frequency on the vertical or y-axis, also known as the ordinate. Then we draw a bar centered on the first class up to the height of the frequency of that class. Here we, at the class 1, we only have one observation, so we just draw the bar at 1 on the x-axis up to 1 on the y-axis. Next, we're going to draw a bar for the second class up to the frequency of that class, which was 2, right? And for the class 3, we repeat for all the classes. So here's a nice picture of our data. And several things immediately leap out about the data, stuff that probably wasn't obvious from the raw data. Alright, it's obvious in this simple example raw data, but with real data, with dozens or hundreds or even millions of observations, it wouldn't be so obvious what the shape of your distribution was. So, first and foremost, most observations are clustered in the middle. There's a tendency to be in the middle, also known as central tendency. We'll talk about how to characterize central tendency in a later video. Also, it looks more or less symmetric on either side of the center. We'll talk about how to measure the symmetry also in a later video. Finally, while there is a central tendency, there are some observations that are very big or very small, but they are very few. It's rare to be very big or very small in most distributions. All right. Now, in the next video, I'll cover a much more complicated case, the grouped frequency distribution and grouped frequency histogram, which are kind of hard. At least they were hard for me to figure out how to do when I was beginning. But for now, I just want to point out another thing that took me forever to really get when I was learning statistics. I kept seeing these normal distributions, but I wasn't making the connection with the frequency histogram. I kind of got the frequency histogram, but it didn't click that those smooth curves were really just the same thing for many, many more observations. In fact, theoretical distributions, which is what the normal distribution is, technically are done on something that statisticians call the long run, which literally means an infinite number of observations. So the height of the normal curve represents probability, just like the height of each bar in the frequency histogram represents frequency, or how many of them there are. It's a little bit more complicated with the normal curve because it's actually a continuous curve or continuous distribution. So technically, there's no probability for a single point. You have to use some calculus to get a probability out of the thing. But for the sake of developing some intuition, you can think of the height of the curve as at least reflecting probability. The higher the curve, the more probable it is that you'd get a value in that part of the distribution. All right, I think that's going to do it for this video. We'll see you on the next one.